Hello everybody and welcome back to my channel. My name is Dave. Today we have a very special video. This video was requested by Randy from Little Rock, Arkansas, who is taking a summer course in calculus. In this video, we'll be looking at the following word problem. Sneaky Pete, a pirate, is after some treasure. According to his map, the treasure is located on a small offshore island. To get there, he can run due east for 12 kilometers along the shoreline, then swim due north a distance of 5 kilometers to the island. Pete, however, wants to get there first as he thinks the other pirates also want the treasure. If his average running speed is 15 kilometers per hour and his average swimming speed is 8 kilometers per hour, how far should he run if he wants to get there in the shortest time possible? Okay, so to begin this, I think it's a good idea to draw a picture. So in this picture, Pete can run from A to B, a distance of 12 kilometers, and then he can swim due north to point C, a distance of 5 kilometers. However, Pete assumes that there might be a faster way to get to the treasure, so he will run a distance of X kilometers along AB, and then he will swim along a diagonal from that point to point C. So we'll let X be the distance that he runs and T of X be his total time. So Pete will run X kilometers, and it's obvious from this that the time that it takes him to run this distance is simply X over 15, the distance over the velocity. Now the distance that Pete swims, the orange arrow has a length of the square root of the quantity 12 minus x squared plus 5 squared. This is because we can use the Pythagorean Theorem, which says that the length of the orange arrow will be the square root of the blue segment squared plus 5 kilometers squared, or the green segment squared. So the time that it takes him to swim this distance is simply the square root of the quantity 12 minus x squared plus 25 over 8. And therefore his total time, t of x, is equal to x over 15 plus the square root of the quantity 12 minus x squared plus 25 all over 8. So at this point we've found our equation, and as we know, to find the maximum or minimum, we should find the first derivative. So let's do that now. We're going to focus on the second part of the derivative first. And to do this, we have to use the chain rule. So when we use the chain rule, we are going to get 1/2 times 1 over the square root of 12 minus x squared plus 25. However, we have to multiply this by the derivative of what's inside, which is 2 times 12 minus x. And we also have to multiply by the derivative of 12 minus x, which is simply -1. When all of this is multiplied together, the 1/2 and the 2 cancel, and we get -12 minus x over the square root of the quantity 12 minus x squared plus 25. Therefore, the first derivative of t with respect to x is equal to 1 over 15 minus 1 over 8 times 12 minus x over the square root of the quantity 12 minus x squared plus 25. Now that we've found the first derivative, we now have to set this equal to 0 and solve for x. So we'll do just that. We'll write down that 0 is equal to 1 over 15 minus 1 over 8 times 12 minus x over the square root of the quantity 12 minus x squared plus 25. And we will then move the 15 over to the right-hand side. Then we will cross multiply and we will get 8 times the square root of the quantity 12 minus x squared plus 25 is equal to 15 times the quantity 12 minus x. So once we have this, we can then take the square of both sides and distribute on the left-hand side. This would give us 64 times 12 minus x squared plus 1600 is equal to 225 times the quantity 12 minus x squared. At this point, we would see that we in fact have a 12 minus x squared on both sides, and therefore I would subtract a 64 times 12 minus x squared from both sides. This would leave me 1600 equals 161 times the quantity 12 minus x squared. And at this point, I could then solve my equation. I would get that x is equal to 12 minus 40 over the square root of 161. Now, if you were doing this on the AP, it would be perfectly fine to leave your answer in this form. However, Pete, he might want to have an approximation of how far he should run, and in this case, x would be equal to approximately 8.848 kilometers. So this is the video, and this is the final answer. I hope you enjoyed it, and if you like this, please subscribe and give me a thumbs up. Thank you very much, and I'll see you next time.